Welcome to this presentation of the Rotary Club of North Bethesda, Maryland, USA. Our club was established in 1974. We meet every Friday morning at 7:45 a.m., and we often invite guest speakers to give presentations on all kinds of interesting subjects. Please contact us through our website at nbrotary.org. And thanks for watching. Our speaker today is Holly Jamesen Carr, Director of the U.S. Department of Energy's Solar Decathlon. She will be introduced by North Bethesda Rotary Club member Carmela Carr.
She's led tenant energy efficiency efforts at DOE, redesigning DOE's Green Lease Lenders Program. While on detail to the Overseas Private Investment Corporation in 2018, she developed a Build It Better program, incentivizing international development construction projects to improve efficiency and incorporate renewable energy into design. Previous to her work at DOE, she managed dozens of private, public, and federal sustainability projects, assisting clients to implement environmentally preferable strategies for design, building designs, construction, and occupancy. She is a LEED accredited professional, a certified energy manager, and an EDGE expert. So I turn it over to you, Holly.
Thank you so much. Can you hear me okay?
Yeah.
Okay. I'm sorry you had to listen to all of that. I have been with the Department of Energy for about 7 years and about 3 years working directly with the Solar Decathlon, and it's really been the pleasure of my career to work on this program. I'm interested to know if folks, since you are all mostly, I think, local to the DC area, it sounded like maybe one or two of you are out and about, not in Bethesda right now, but have folks had experience with Solar Decathlon before? Has anyone attended one of these events?
My wife and I attended one when it was on the mall a couple of years ago. Is it still on the mall?
It is not still on the mall, and I will tell you a little bit about that story. But so you saw it on the mall.
Yeah, and it was amazing. You can go into the houses and climb around, and I think the University of Maryland did pretty well, didn't they? I don't remember.
Yep, #1. Yep, okay. Exactly.
Yeah, it was very impressive.
We'll talk about some of the local schools that have participated and so forth, but just wanted to get a sense of if folks had attended the event before.
Let me stick a word in. We've attended them as well, and we're very impressed.
Oh, great. Good to hear. I attended several times before I was even involved with Department of Energy. I attended as, just someone living in DC who happened on the mall and found it. And I too thought it was absolutely amazing. And, the things that these students are able to pull off at age 20, 22, 23, really, really admirable. So I am going to try to show some visuals here. I would love for you all to ask questions and have some conversation during this, so don't think of it as a full-on presentation. Let me share my screen, and you can give me a thumbs up if you are seeing the slides. I'm sharing now. Are folks seeing the slides?
Yeah, it looks good.
Okay, great. I'm going to go ahead and leave it with the little mini slides on the side so that I can still see you. Otherwise, it takes over the whole screen and I can't see you anymore. But we'll start here. And as you heard, the competition itself is a collegiate competition. It's for universities and colleges only. And our goal is really to prepare the next generation of building and design professionals to construct high performance, low carbon buildings powered by renewables. And that's what we've been doing since 2002. You can see a photograph down here on the bottom of this slide, which was, I think, our very first event on the National Mall. And it looks like it's a real like paper photo, kind of grainy. So definitely one of our earlier events out on the National Mall. Another one up here on the top from a more recent event on the National Mall, and you can see the homes that were constructed. And then you'll see how we've evolved over time, and we've had to evolve really quickly in the past 2 years, as you can imagine. I will say that not only have we evolved in the US, but this program has grown internationally. We now have 6 international competitions, one in South America and the Caribbean. We have a Solar Decathlon Europe, Solar Decathlon Africa, which started in 2019. Solar Decathlon Middle East has held multiple competitions and is about to hold its 3rd competition starting in October. Solar Decathlon India just kicked off this past April with a competition, its first competition, and then Solar Decathlon China, which has also held multiple competitions and is planning its next one for 2022. So really exciting to see the growth around the world of this competition. We think with all of the competitions that have happened internationally that we have impacted about 50,000 students around the world with this program. So on the US side, this is what our program looks like. All of the competitions internationally are a little bit different, but this is what our program looks like. What I just showed you photographs of, those houses on the National Mall that some of you have been to, that is the build challenge. And that's the original element from the very first Solar Decathlon competitions. It is a 2-year, typically a 2-year design and build competition where student teams build. In the past, they have built homes, deconstructed them, brought them to the National Mall or Colorado or California. We've also held events out in those 2 locations, reconstructed them in the Solar Village and competed them for a couple of weeks and made them available to the public for tours. So that's what most people are familiar with and have visited. In 2018, we added a design challenge to the Solar Decathlon platform in the US program. And whereas the build challenge is a 2-year competition that's design build, design challenge is a 1-year design only competition. So student teams, again, higher ed, university teams are designing but not building, both residential and commercial buildings that are zero energy. So that means that they are designed to be super efficient and to have renewable energy that meets the needs of that building over a 1-year period. And in the design challenge, we added a lot more divisions or building types that students can design. We're going to need professionals out there who can design all types of buildings to this performance level. So we now have new housing, retrofit housing. So most of the houses out there in the world are already built, and we're going to need to be retrofitting our homes to that super high performance standard with renewables, and then attached housing on the residential side. We also have multifamily buildings, office buildings, and schools that students are designing to zero energy in that competition. It is a decathlon, so there are 10 contests always in the event. You can see those contests for our upcoming event down there on the bottom. We changed those a little bit for just about every competition. We are responsive to the interests and the evolution of technology and policy over the years of the competition. So I will highlight this Embodied Environmental Impact Contest, which we added a year or so ago to the competition. And that really looks at the full life cycle of these buildings that are being designed. So until now, we've looked at only the operational performance of these homes and commercial buildings. And we realized that to address carbon emissions, we really need to be looking at not just the performance when the building is operational, but we need to be looking at the energy and the resources that it takes to get resources out of the ground, get those resources transported to the site, the construction energy, and even the deconstruction energy required at end of life. So students are now looking at the full life cycle of the buildings that they design. They're often changing the materials that they're using to construct these buildings so that they can reduce that embodied environmental impact. So going from steel structures perhaps to wood structures, or from fiberglass insulation to more natural insulations to reduce that impact. Any questions on the structure here and the way the program is set up?
Not yet.
So I did want to show you also where we are in the process and how those two competitions work together. We are actually right here at the beginning. We just finished a competition phase in April, and I'll tell you all about that and brag about what our students did in just a second. But we just finished that, and we are right on the cusp of beginning a whole new 2-year cycle of Solar Decathlon. And a 2-year cycle includes 2 years of build challenge, where the students are designing and constructing. So we'll have a number of teams doing that down here over the next 2 years. And then 2 cycles of the design challenge. And we really like this design challenge, I'll add, because it gives a lot of schools an on-ramp to participation in this program that otherwise would not have had the financial ability or the faculty commitment, or there are all kinds of things that keeps teams from being able, keep universities from being able to commit to this big design and build a house. And so we have a lot of teams that start out with this lighter lift, which is the design challenge, and then they may over time transition into the build challenge and gain confidence and move into that. We have about 1,000 students per year participating in the design challenge as well. So it gets a lot of students exposure to the program and the design concepts and the building science education that we offer without full commitment to building a house. Just a little bit more on the building science piece. That's really core to why we initiated this competition, is that Department of Energy felt like building science was not integrated well into architecture programs at universities across the country. It just hadn't been a part of design programs in the past. And so we include and require about 10 hours of building science education through our program. If professors are already teaching building science in their classes, we don't make them do it twice, but for universities that don't have that in their program, we offer that. And our students can do all of these modules online and use that information to inform their zero energy designs. So I did want to tell you a little bit about the past couple of years. As you can imagine, it's been intense. It has changed a lot. I forget who it was, maybe Daniel, who was asking if we were back on the National Mall or we'd be on the National Mall in the future. We were intending to be on the National Mall in July of 2020. And that was going to be our kind of grand finale on the National Mall. The National Park Service had given us permission to be out there one more time. And as you can imagine, COVID threw a wrench into that about 3 months before we were planning to be out there. So we moved from having all of our teams transport their homes wherever they were in the world, coming to the National Mall, to a local build scenario. And this is what we ended up with in the summer of 2020. We ended up with 9 homes constructed all over the world, 6 homes in the United States, and 3 international competitors. And all of those homes were constructed wherever they were in the world, in situ, and we went to them in terms of the competition and taking measurements that would normally have been taken on the mall or in Denver, Colorado at the facility there that we used in 2017. I'll just give you a quick overview of these homes. This is University of Waterloo. They built a home in Northern Ontario with Habitat for Humanity. They basically took a spec home that Habitat builds in communities, and they revised the design to be zero energy. So gave it a much more efficient envelope, more efficient windows, more efficient equipment, put solar on top, made it zero energy, so the residents will have essentially zero energy costs for the life of the building. And this home was built in a First Nations tribal territory in Northern Ontario for a First Nations family. In Fraser, Colorado, CU Boulder built this home in what is ostensibly the coldest town in the lower 48 in Fraser, Colorado. Beautiful home. I'm gonna give you a chance to see some of these homes in just a minute, but see inside some of these homes. But this was, for one thing, a test of cold climate heat pumps. If any of you are familiar with heating and cooling equipment for homes, something that we've been working on for a long time is trying to get super efficient electric heating for homes. And one of the biggest challenges there is in cold climates where heat pumps traditionally have had a tough time. And this home uses 2 heat pumps to take care of that and has performed really, really nicely so far. And Weber State, excuse me, Weber State University in Ogden, Utah, partnered with the city. They took an abandoned corner lot in downtown Ogden and built this beautiful bungalow on the property. They actually auctioned this off to Weber State graduate couple. And soon after they moved into the house, they had their first baby. So we like to claim this baby as our Solar Decathlon baby. His name is Maverick. But just a really sweet story and a beautiful home that you'll see. I won't go through all of the homes in, excuse me, in such detail, but our team Netherlands built sort of a spec home for a larger neighborhood that will be constructed. And so it's anticipated that this home may be constructed multiple times in that neighborhood as folks are interested in its design and want to move into it. It's also kind of modular. So a number of these homes are modular, and you can see particularly Netherlands and Las Vegas, those were 2 homes that were planning to just ship their home directly to the National Mall and be on the mall. So they were built size-wise to fit on the walkways of the National Mall because we could no longer be on the grass. So you can see they were sort of designed to fit right there on the National Mall. Team Chile built a home in cooperation with their regional government. This was a home designed to serve as a prototype to be built for many folks who lost their homes in wildfires that tore through that area in 2017. Kansas State also worked with an affordable housing group to build this zero energy home in a very difficult and poverty-stricken neighborhood outside of Kansas City. This is Illinois, University of Illinois' home, built also in collaboration with Habitat for Humanity. And University of Denver. I loved this project. This is our first ever existing home retrofit to zero energy in the Solar Decathlon. So they took a 1950s style ranch and upgraded the home with better envelope, better equipment, and solar to dramatically improve that performance. So any questions on these individual projects from the 2020 event?
Are these houses off the grid?
No, they are not. I don't think in any case. We actually don't encourage them to be off the grid because ultimately what we want homes to be able to do is to interact with and support the grid. So if they're producing excess power at any given time, they can send it back to the grid and have that communication with the needs of the grid and provide, not just take. So I don't think any of these homes are off the grid. So this is just a shot of our student teams doing some of their contests. So one of the contests that we have in Solar Decathlon, the student teams have to prepare and serve a meal to guests in their home. So we try to make some of the contests very practical, like, you know, can you use your kitchen equipment, and does it work to make a meal and serve to other people? So it's not all measurements like you see over here, where we're looking at how much energy the home is producing over time. We sent out a big box this time. We couldn't bring the homes to us and hook them up with all of our measurement equipment to measure the 10 contests. We had to send big boxes of equipment to each home, wherever it was in the world. We had volunteers from alumni from Solar Decathlon's past who are now professionals out in the world. And I mentioned there are about 50,000 of them, so we had lots of folks to choose from. We had Solar Decathlon alumni in many cases proctor these measurements, make sure that everything was set up properly, watch the measurements being taken, watch the results being recorded, and then digitally send them back to us. So we had to turn really quickly when COVID happened and figure out how to do all of this remotely, but you can see our students figured it out. Many of them completed their designs and even constructed their homes, mostly while not in school. Their schools closed down, they moved home. In some cases they moved back, but were very restricted about how much they could be on their site by their universities. So the fact that they were able to get these homes completed and do these measurements is really kind of a miracle. So, and as you might imagine, in normal times, we would have our juries for each of the 10 contests. We have architects and engineers and various building professionals serving on juries for each of the measured or the presentation contests. They would walk into the homes, the students would present to them, they'd look around, right? We could do none of that this time. Everything happened on Zoom, just like we are this morning. And the students were able to walk their juries through their homes virtually, which I'll show you in just a moment, as well as, you know, talk to and discuss their projects with the juries through a Zoom interface. And this is how our students, in many cases, were able to walk juries and the public through their homes. This is the Solar Decathlon Virtual Village, which we have never done before, but we wanted to create some digital representation of what was going to happen in the summer of 2020 on the National Mall. So I'm going to try to minimize this and show you the real thing. Are you seeing my web browser right now?
Yeah.
As opposed to my PowerPoint. So this is solardecathlon.gov/virtual_village. If you want to go there and check it out. I love to visit this website. It's my happy place. You're standing on the National Mall. You can see the Smithsonian Castle right there in front of you. And you can actually go in and see all of the homes rendered. And then you can go click on their targets. And you can click on the door here and go inside for a 3D virtual tour. If you've ever looked at real estate online and walked through a home this way, this is basically what we did for all 9 of the homes. We created these virtual tours. I love this one because it's, you know, you're walking into a home in Chile right here, and you can actually look out the window and see these amazing views. And, you know, look at every nook and cranny of this home. And you can see it, you know, it's not high tech, but yet it is high tech because it's zero energy. So I think one of the big differences that we are seeing in solar decathlon homes these days is sort of the every home possibility of it. It's no longer these UFOs that drop down on the National Mall and are these crazy designs that wouldn't actually be in a neighborhood. In many cases, these homes are the home next door, particularly if you remember the one from Ogden, Utah, the bungalow. So are you all able to see us walking through the home?
Yeah, fantastic.
Okay, so you can do this right on your machine. In fact, I can put it in the chat, the URL. And you can just hop in and, you know, go on a little walk in Solar Decathlon anytime you want. And this we did under duress because we wanted, you know, we had to do something in COVID times to showcase our students' amazing homes. I'm going to try to close out of this one because I want to show you some other ones. How much time do I have? I don't want to go over.
Till 8:30.
Okay. All right.
With
With a little time for Q&A, please.
Yeah.
Great. Would you like to see one more house? It's right here. I could show you the winning house. Actually, I might show you two more houses if you don't mind, but we'll do it real quick. This is the winning house, CU Boulder House. So we'll click on the door. We'll hop inside here. So this is actually the owners of this house, or a young couple who went to Solar Decathlon 2017, which was in Denver, Colorado, and they were touring a house, and they were touring behind some students who were saying, "Oh man, this would be so awesome! I want to be in this competition." The students in front of them were saying, "You know, I want to do this competition. This is so awesome," and they started talking to those students and said, "Hey, if you guys actually do this competition, here's our phone number, call us because we want to build a house. And if you would, we would buy the house if you would work with us to design it and make it happen in Solar Decathlon." And that's exactly what happened. So this young couple, they had a piece of land. They worked with the CU Boulder students that eventually did join as a team in Solar Decathlon. And they designed and built this house, and now they're living in it and loving life.
Are the windows typically, it looks like the windows in many of these houses, not the one in Chile, but these houses are a bit smaller than they might otherwise have been. Is that right?
I wouldn't necessarily say so, no. Many of these houses are using triple pane windows.
Yeah, I see this one is. I see the triple.
So they're much more efficient. Yeah. And this home was designed, so it's kind of hard to see from inside, but it was designed to have like the main house here, and then it has an accessory dwelling unit on the side. And here's, let's see, here's the accessory dwelling unit. So you walk into the main house right here, and then you walk over here and there's a bedroom and sort of living room and kitchen over here. So it's meant to be also a rental unit. They live up in a ski town, and so there's a real shortage of housing for folks who work at the ski resorts. And so their intention was to be able to rent this small unit on the side of their house out to seasonal workers and so forth.
Or an Airbnb, right?
Kind of an Airbnb, yeah, yeah.
So does this house have no energy consumption?
That's correct. It's designed to be a zero energy home. And this was the winning home. This was
What do you mean zero energy? I mean, in other words, to turn on the heat doesn't involve any energy?
Thank you. It means that the home produces as much energy as it uses in 1 year. So in any given day, it may take from the grid or give back to the grid, but over 1 year, it produces as much energy and sends as much energy back to the grid as it takes from the grid.
Does it use batteries for that?
That particular house does not have batteries, but I think they will, if they will eventually install batteries. They did not for this competition.
So do the residents have to alter their lifestyle in order to make these homes zero energy? In other words, if they turn the AC on to 68 in the middle of 100-degree weather, I mean, won't that kind of put a strain on the power consumption?
Yeah, the house is designed so that normal usage would allow the home to be zero energy. So for example, this is the Weber State home that I mentioned, where the recent graduates from Weber State University have moved in. And, you know, this is a small family that now lives in this house. There is no expectation that they would live their lives any differently in this house in order to maintain zero energy. You're right. If they run the air conditioning at 68 all summer long, they're going to have a tough time. But, you know, they run it at 72, 74. That's what the expectation is for, you know, normal usage.
I guess when that young couple gets older, and some people may become more hot or cold intolerant.
Right, right. And this one actually does have storage, if I remember correctly. You can see the inverter here and some of the equipment. And you can go down in the basement. You can see the equipment room down here. They're all using electric hot water heaters, heat pump hot water heaters and heat pumps. This one has like a 12-inch wall in the lower level, heavily insulated. So the homes are super insulated to be able to achieve this level of performance. And they had, I believe they calculated about a 3% cost increase over, you know, the normal home that they would have designed and built here.
So tell us a bit about the equipment. I've seen a heat pump water heater advertised I've seen them at the Home Depot. So it's clearly something that's commonly available. But is that true of all the equipment, or is it something special or test in a test phase that you're using? Yeah.
So the tagline that the faculty advisor from Weber State used, he said this all the time about this home. Everything we put in this home, you can buy at Home Depot. Uh-huh. And I think that's really the threshold we have crossed in this particular solar decathlon, is that now these things are out there. And now these things, I wouldn't say they're affordable. They are affordable. They're not the cheapest thing on the market, that's for sure. But everything you can get at Home Depot to build this house. There's nothing crazy here. And you can see the design of this house. There's nothing crazy, right? It's a lovely, I want to get outside, but it's a lovely bungalow on a normal street, fits right in. Yeah.
I was just going to add, it's not so easy to find out about this, but in many cases, for example, for the heat pump water heater, our local Pepco gives a credit. So there are some offsets to the cost.
That's exactly right. And we're trying to make that more the case. I think, you know, there's recent legislation that has been passed or is partially passed, where, you know, a lot of those rebates and credits, you'll start to see more of that for some of this equipment. I think heat pump water heaters and heat pump heating and cooling are two things that you're going to see really encouraged and incentivized in the years to come.
Just a quick question. Is there any recognition given to the need for air exchange on a regular basis? The tighter these houses get, the least it becomes difficult to do the air, fresh air.
That's a really good point. And we ask our student teams to build to DOE's Zero Energy Ready Home Standard. So this is a certification that DOE has developed over the past 5 or 10 years. And a big part of the Zero Energy Ready Home certification, it's not just energy performance, it's also very much indoor air quality for exactly the reason you mentioned. The tighter the home, right? You don't get that natural flow through the windows and walls that that most of us get. And although we don't want that for energy reasons, it is good for air quality reasons. And so we have to get that other ways when we have such a tight envelope. And that's built into our certification and what these student teams designed to.
So Holly, thank you for the presentation. I work with a local nonprofit called Solar Household Energy, and we do solar cooking solutions.
How neat.
We have been involved in several of the demos with down on the mall for the past several years, and we love to work with the Decathlon folks. I'd like to offline, maybe I'd like to send you an email and tell a little bit more about what we've been doing. We've been partnering with other organizations, and we're in contact with John Mitchell at DOE, who has been working with this development of solar cooker standards over the past several years. So we would love to be able to somehow have a demo of our solar cookers down on the mall in connection with the event.
So I just put my email into the chat there. I thought I had a slide with that too, but I'll certainly add one and I can send the slides over to you all, but please do reach out about that. We will not be on the mall in future years. Because we tried this COVID local build everywhere in the world. And we did that under duress and it was great. And we are going to continue to have student teams build their homes wherever they are in the world. But there's still a great opportunity, I think, to talk about your project and how it might fit into what we're doing or other programs at DOE.
Great. So, yeah, we're particularly interested in saving energy in kitchens.
Great.
Yep.
And if anyone else on the line, I put this "we need you" slide out because I know you never know where architects, designers, construction management folks are going to come. So if there are any other folks on the line who have a personal interest in this or a professional interest and might like to get involved as mentors to students, or who knows how we might be able to work together. So feel free to reach out to me at that address if you have ideas on that, or if your company would like to sponsor a solar decathlon. We're always looking for sponsors as well.
Is Maryland involved this year?
So Maryland was not involved in the 2020 event. We are taking applications right now for our 2023 event. Applications will close in October 26th, and then we will know if Maryland is involved.
Okay.
Yeah.
Awesome. This was wonderful. Thank you. I enjoyed walking through the Solar Village on Village. I forget what year I walked through. It was beautiful. So I find this event truly inspiring. So, yes.
Great. Well, thank you so much for the invitation. It's fun to be able to talk with folks about it and share it a little bit.